Derinkuyu Underground City. Derinkuyu is one of the deepest and most sophisticated underground cities ever discovered, descending around 60 meters below the surface in what is now Turkey. It could accommodate up to 20,000 people, along with animals, food storage, and essential supplies. The city included schools, churches, kitchens, and advanced ventilation shafts that allowed fresh air to circulate across multiple levels. Massive circular stone doors could seal off entire sections to protect against invaders. Its design suggests it was used repeatedly over centuries as a secure refuge during periods of conflict. Kaymakli Underground City. Kaymakli is another major underground settlement in the Cappadocia region, but it is structured differently from Derinkuyu. Instead of going extremely deep, it spreads across a wider area with multiple interconnected levels. The city features living quarters, storage rooms, wine cellars, and stables, all carved into soft volcanic rock. Narrow, low tunnels force people to move in controlled ways, which also made defense easier. Its layout reflects a more day-to-day living environment where people could function as a community underground for extended periods. Naour's underground city. Naours in northern France consists of a large network of man-made tunnels carved into chalk with over 300 rooms and long corridors. It was primarily used as a hidden refuge during times of war, especially during World War I. The space included chapels, wells, and areas for sheltering civilians and soldiers. Unlike ancient underground cities, Naour was not meant for permanent living, but for temporary protection. The inscriptions left by soldiers on the walls provide a rare historical record of its use during conflict. Kuberpedi Underground Homes. Kuberpedi in Australia represents a modern adaptation of underground living, driven by extreme environmental conditions rather than warfare. Temperatures in this desert region can become dangerously high, so residents build homes underground, known as dugouts, to maintain a stable indoor climate. These homes include bedrooms, kitchens, and even hotels and churches, all carved into the earth. The underground environment stays cool in summer and warm in winter, making it highly energy efficient. It demonstrates how underground architecture can be both practical and sustainable today. Beijing Underground City. Beijing's underground city was constructed during the Cold War as a massive defensive shelter beneath the capital. It reportedly included thousands of interconnected tunnels, rooms, and facilities, such as hospitals, schools, and even small factories. The goal was to protect large portions of the population in the event of nuclear attack. While much of the system is now closed or repurposed, it remains a powerful example of large-scale emergency planning. Its existence reflects the geopolitical tensions of the time and the need for urban survival strategies. Montreal Underground City. Montreal's underground city, known as RESO, is one of the largest fully functional underground urban networks in the world. It connects shopping centers, office buildings, hotels, metro stations, and residential areas through over 30 kilometers of tunnels. Designed to protect people from harsh winter weather, it allows daily life to continue comfortably below ground. The system is fully integrated with public transportation, making it a key part of the city's infrastructure. It shows how underground space can enhance convenience and urban efficiency. Seattle Underground. Seattle's underground is a unique case created by accident rather than design. After a major fire in the late 19th century, the city rebuilt its streets at a higher level to avoid flooding issues. The original ground floors of buildings became buried beneath the new streets, creating an underground network of sidewalks and storefronts. Today, these spaces are preserved as historical sites and can be explored through guided tours. It highlights how urban evolution can unintentionally create underground environments. Petra subterranean structures. Petra in Jordan is famous for its monumental rock-cut architecture, but it also includes a network of underground chambers, tombs, and water systems. These subterranean spaces were used for storage, burial, and water management, which was critical in a desert environment. Sophisticated channels and cisterns helped collect and store water from seasonal rains. The integration of underground and surface structures demonstrates advanced planning by the Nabatean civilization. It reflects both practical engineering and cultural significance. Cappadocia tunnel networks. The Cappadocia region contains extensive tunnel systems that connect multiple underground cities, including Derinkuyu and Kaymakli. These tunnels allowed people to move safely between settlements without exposure to threats on the surface. They include hidden entrances, ventilation shafts, and defensive choke points. The interconnected nature of these systems suggests coordinated planning across communities. This network transformed individual underground cities into a larger regional survival system. Burlington Bunker. Burlington Bunker in the United Kingdom was a top-secret underground facility built during the Cold War to ensure continuity of government in the event of nuclear war. It was equipped with offices, communication systems, living quarters, and infrastructure to support hundreds of officials for extended periods. The bunker remained hidden from the public for decades. Although never used in an actual crisis, it represents the extreme measures taken to prepare for global conflict. Its design focused on long-term survival and operational functionality. Helsinki Underground Master Plan. Helsinki has developed one of the most advanced modern approaches to underground space through its long-term master plan. The city uses underground areas for parking, data centers, utilities, sports facilities, and emergency shelters. These spaces are carefully mapped and regulated to avoid conflicts and maximize efficiency. Some underground areas can be quickly converted into shelters if needed. This forward-thinking strategy allows the city to expand without overcrowding the surface. It represents a new model for sustainable urban development. Paris Catacombs. The Paris Catacombs form a vast network of tunnels beneath the city, originally created from limestone quarries used for construction. In the 18th century, they were repurposed as ossuaries to house the remains of millions of people due to overcrowded cemeteries. While not designed as a living space, the catacombs extend for hundreds of kilometers and represent a massive underground system. Today, parts are open to the public as a historical site. They illustrate how underground spaces can evolve in purpose over time.